Hey people, is the mic working? I think so. Nice. Yeah, the audio ducking works even though the channel is disabled in OBS there, Emil. So it does function as a mic jack in that sense. Yeah, my camera's still set to the normal lighting scene, which isn't it right now, so it's a bit bright maybe. It's a bit bright. Good evening, ladies and gentlemen, says Johnny Bergdahl. Okay, let's move down the music slightly. Good evening. Well, welcome to the pre-stream. It's been a while since we had a good pre-stream where I didn't fail and start too late. But today I feel in regards to drinks, because we have Coke Zero and Coke Zero. They're freezing cold, as you can see. So we'll have a Coke Zero. What are you guys having? Hello there, John Kuster and Jose De Pino. Earth Gamer XE is here. Nice. Nico Bill was first. Okay. So no, not new lighting. No. But the sun is still out. I mean, I really need a basement to build my studio in, because who needs the sun when you have LEDs, right? I mean, what are you going to do? How about a water with bubbles? No, I'd rather have a water with bubbles and some taste. Let me check if the top cam is working. Yes. Oh, what's this? This shouldn't be here. Hold on. Need to fix this. There. That should do it. Yep. Well, I guess I need to zoom it in slightly. There. Excellent. Cool. Well, I'm working on a giant video. It's over an hour long. But it's not done yet. And I want it to be a good video because it's going to be important. And, well, so I was like, okay, then let's live stream. But I didn't really have a topic. And then I remembered, like, I do have some prototype boards here. Let's play with those. Gamer XE is drinking 28 Black Acai energy drink. Got 4 for free in my local store. But are you drinking 28, or is the brand called 28? So let's wait for some people to arrive. Error. YouTube is not receiving enough video to maintain a smooth streaming. What are you talking about, YouTube? My settings haven't changed. Did we drop frames? No. We didn't drop any frames. We're sending 16 megabits of pristine, well, not 4K, because YouTube doesn't support that data. I don't know. Oh, good news, since we're in the pre-stream anyway. Wait, my microphone might be a little bit far away. Is that true? Is my microphone far away, or is it okay? You guys let me know. But this week, I actually now have a fiber connection in my wiring closet. They brought it in from the outside to the inside. So now I'm just waiting on the provider until I can change my coaxial connection, which, you know, it's 600/40. It's okay. To 1000/1000 over fiber. Sound is fine. Nice. So yeah, I'm excited for that, especially for the upload. Other than that, it's been okay. I mean, coaxial works fine. Oh, and it's gonna cost half. So I'm getting like double or 20 times as much bandwidth upload, and it's going to cost half. That's going to be good. Stream is perfectly fine. Excellent. Well, it's slightly overexposed, but that'll adjust when the sun goes down. What will 1G cost over there? $32.50 a month. Or rather, you paid in a year and then it was $32.50. $800 a month? What? No, oh, sorry. That was a bit much. Let me turn that down a little bit. There. No. €32.50 a month. let me check what it costs nowadays, because I got this contract like, I don't know, years ago when they were promoting the fiber. So let's see. Fiber product. I only want internet. And then it's €410 a year. So it got slightly more expensive. But that's still... Oh, no, yeah, okay, it's got slightly more expensive. So €34.16 a month. And I'm paying $32.50 a month. Yeah, that's okay. $15K to install. Holy shit. No, the installation was free. And this is the best subscription you can get, because it's the cheapest one. And they actually give you a media converter from fiber to U2P or Ethernet. So that's perfect, because I already have my own routers. I use router board for everything, etc. And I own wireless and firewall and things like that. I don't want an expensive doing all kinds of crap modem. I don't even need the fiber converter, to be honest, because I can just push the SFP into my router. But okay. Yeah, but this is the bring your own router subscription, and you just get a media converter, and you can just steal the SFP from the media converter and plug it in your own box. That's fine too. It's excellent. That's like everything we've been trying to do for all those years, and now they offer it for cheaper, which it of course always was. But the other providers always shove a Wi-Fi modem down your throat and then tell you it's free, except you're paying for it in the back end. It's so stupid. Oh, you can ask for a free static IP. Well, that I'll do for sure. Yeah. So yeah, that's going to be good. But, you know, it'll I don't know, maybe 1 or 2 weeks more before the provider contacts me and says like, hey, we're ready to activate your link. And I'm like, okay, let's do it. Oh, that's not too bad, Jose. Andy, €120 a bit much, but still, I'd do it. Yeah, Rob, we're talking about Tweak, that's right. It seemed like a good provider for what I need, and that's basically pure internet. I don't need to make phone calls. I don't need any TV. I don't need any weird-ass subscription to whatever else. I just want internet. That's it. I don't want anything else. I never have. They've been forcing everything else down my throat for the past 20 years. I never wanted it. I don't watch TV. The coaxial cable is going straight into the modem. There's no TV here that takes coax. Anyway. Oh, that sucks, Emil. Yeah, I get bundling is how they make dollars, I guess, especially if no one uses it anymore. Right, I was going to open my drink. I almost forgot. Yeah, seems so, Rob. And we'll see how the provider... I guess Rob also has Tweak. We'll see how I like them, but they should be good from what I've heard. What can be more important than this, Philip? Should I label the drink? Well, we can label the next one. What should the next label be? I'll print it already and put it on the other can, okay? Yeah, for over here, it's basically one provider or network entity is putting down the network, and then the network itself is open to like many providers. So the provider doesn't own the fiber, and the fiber operator doesn't. Well, I think they have a provider actually, or internet or ISP, but I'm not sure. I think that's a good way to do it. Okay, Rob de Graaf says, I use Tweak for about 3 years now. No outage, not even minutes. Nice. Oh, you have a headache breakout. I'm going to try and get a scan made to see what's going on. Whoa. Okay, that sounds bad. Well, then definitely don't stay here, Philip. You drunk messages from Philip. Well, he'll be maybe high on painkillers, but I don't know. Yeah, here in the Netherlands, the whole provider situation is pretty good. There's a lot of competition, also between like ADSL or VDSL and coaxial before that, and now there's also fiber. And Ziggo, which I had, the coaxial connection is generally fine. I don't really have issues with it, except I'm paying 70 euros for 600/40, and now I'm paying like less than 40 euros for 1,000 on fiber. So yeah, it's no competition there in my opinion. But yeah. Hey Al, Quindor, do you think you can create an ESP32mm motion sensor? Sure, that's not too hard. It's actually the alternative topic of the stream, but I decided not to do it this time. So you need to get some of some of these. Are we talking about the millimeter wave stuff? So these guys. Let's see if the zoom is working. We're going to need that later tonight. There. So this is a millimeter wave module from AliExpress. And it should have a serial protocol that's also easy to integrate into ESP Home. And then you have millimeter wave. Just some serial connection and yeah. They were in not the last Quinbox, but I think the Quinbox before that. So I don't have a link ready for that, but it's a bit dark, isn't it? There. Yeah, that's good. So I do intend to play with those at some point, but I'm not sure when. So, yeah. Oh no, my drawer is too full. Can't wait for the upstream speed tests. Exactly. Uh-oh, my monitor went dark. Oh, and it's back. Okay. Yeah, well, I might be able to up the bitrate. I'm streaming at 16 megabits now at 1440p 60. Yeah, I think that's generally okay, but maybe we could go to 20 or 25. We'll see. So while we're in the pre-stream, I guess we could do something already. I have this cable on my desk, which is connected to my 24-volt power supply, which we'll be using a lot today. And I'm thinking of maybe replacing these plugs with some fork terminals, although or fork crimps, although these would fit in here, I guess. No, they don't fit in here either. Okay, yeah, let's do that. So I'm talking about this cable here, which is connected to my 24-volt power supply, and it currently has wire ferrules on there, but all the new boards use the okay, I guess I can quickly show you a new board. They use the same connections as on the Dig Quad, because I really like those. Now you can make this work. You can get these in there. I've been testing with that all this time. But since I have these terminal on all the boards now, I'm thinking, okay, let's snip these off and let's make some proper forks on them. Right? Now I don't know if I have my crimper here, because I was working in the garage. And I don't. Well, I'll go get it. Let's see. We need some forks. And we need the, let's see, the SD 5.5-4. That's exactly what we need. So we have the red one. Yep, and we have a black one. Please. And we need a red one there. Have a good night, Philip. Hopefully the headache goes away a little bit. Yeah, I need my crimper that's in the garage, but I'll go get it in a minute. Let's snip off these ends here with my heavy-duty snips here. There, that's a clean cut. Okay, let me get my crimper. Hold on. Philip, even though he's sick, still donates €5. Don't you dare blow up anything while I'm out. I'll try. Well, in theory, we're going to fix things today, but we'll have to see. So we're crimping for these. Let me focus that just to make sure. There. We're crimping for these fork terminals, and then you only basically need this much of wire stripped, so that's less than 1 centimeter, I believe. Something like that. Let's see if that's good. Now I can never get it in there without twisting it a little bit. Doesn't need to be much, just to get in there. Could use slightly more. If I push it, it's okay. Right? You can see it poking out just ever so slightly, so that's good. I'll leave it at that. See, I should have twisted it more. No, I'm gonna strip off an additional little piece here. There we go. That should be perfect. Let's do it for the other one too. Okay. So, in theory, the middle one, should go for the big one, huh? I always line it up at the back. Okay. Yeah, it's poking out just slightly over there. There, that's good. Let's give it a double crimp. There. Yep, that's going nowhere. Oh, I squished some of the wires. But that should be good. There. And there. Excellent. Yeah, that's not coming off at all. Cool. And now we have replaced our... where's the other one? I don't know. We have replaced our... There's our ferrules with fork style. Cool. And now, of course, I can't use it on the Mini, but there might be a little trick for that. We'll see about that. So we're at 20 already. So I should maybe just start, the main topic here. We can put this away, I think. Let's do that. So the main topic today is going to be my new Analog PWM boards. I've been working on these since, I don't know, since December or so, or November, I don't remember, somewhere last year. And there's 3 boards that are going to come out relatively soon. But we've had hit a few snags, so we're going to take a look at that today. Let me put them on my desk here. And this one. There. So there's 3 analog boards I'm working on. And what makes these analog boards and not digital boards? Digital LED strips have a little chip on them, or every LED has a little controller on them inside of the LED, or per 3 or per 6 if it's 12 or 24 volt, that makes that each LED can do something else, and you basically send a data signal to it. However, if you have analog strip, those kind of chips aren't there, and the whole strip can only do one thing. You can either turn red off or on, or some other value. So that's a more basic form of control, where the controller actually has to do the actual controlling instead of sending a data signal and then the LED chip itself does it. Now, you can dim these channels by using PWM, so you basically pulse it on and off. And, well, I like doing that for all my main lighting in my house, because where digital lighting is great for RGB and effects and things like that, their quality of white light really isn't great. Actually, it's quite bad. And analog is still king in that regard. Also, some other advantages of analog is with digital, for a single color, you only have 256 levels that it can take. So 0 is off and 255 is 100%. With analog, you can have thousands of steps. So if you want to have a gradual fade or something like that, analog is going to be much better for that. Generally, it's also 24 volt or even 48 volt, and it's cheaper. So there's generally some advantages to using analog strip or lights, but I use it mainly for the much higher quality white light. So today we're going to have a few test strips, but we'll take a look at those in a minute. Let me introduce you the new boards I've been working on. And first up is the, I guess we'll start with the smallest version here. That is the AN Mini. These are code names. Don't know what the actual names will be. They might stay like this, or they might be different. This is a board based on the ESP32C3. You can see this one's already a bit burned because I worked on it already. We'll take fresh boards today. It basically has input terminals here. It's rated for 2 times 5 amps because all of the boards have fuses on the positive outputs. That puts them apart from generic boards you buy out there. It has USB-C input. This is a C3, so it's automatically linked to the USB of the ESP32C3. It's not meant for power, but it's meant for programming and things like that. Then it has, I believe this one has 3 button inputs, 3.3 volt and ground over here. So you can, tinker with connecting buttons or rotary encoders and things like that. It has an I2C connector. So this is a Stemma QT connector. So you can easily connect sensors or more buttons or other kinds of expansions using a standardized connector. And then it has 2 output channels. So the board is compatible with in theory with 5 volt, 12 volt, 24 volt, 36 volt, up to 48 volt. So you can use up to 48 volt LED strip, and it'll do all the power conversion and other things by itself. And then next to having 2 positive output channels, which are individually fused and have their own capacitor to smooth out voltage as much as possible, we have 2 channels for LED strip that are higher power, and then 3 LED channels that are lower power. What makes them higher and lower power? Well, these 2 channels have a MOSFET gate driver in front of the MOSFET, driving it at 5.12 volt, and the other channels don't. So the MOSFETs are driven with 3.3 volt. Now, the higher the voltage you drive your MOSFET at, the higher the efficiency. So these smaller channels will be suitable for up to like 3 amps, and even if you're running at 24 volt, that's still quite a decent wattage. And these bigger channels will be able to do 5 amps or so, although you still have the 2 times 5 amps, so 10 amp limit. Generally what you'll do, you connect an RGB plus CCT strip, you connect the 2 whites over here, and then you connect the RGB over here, because those generally use less power. This board is meant to be relatively small, easy, and as cheap as possible, basically, while still being a good design. I didn't save on the design. All the protection and safety features are still there. The 48 volt support is still there. It still has an ESP. You can run ESP Home on, so connect natively with Home Assistant, integrate there. WLED I haven't tried yet. In theory it should work too. And it still has programming on board, custom buck converter design, etc., etc. But it's meant to be small and cheap. If you want to run, say, an RGB plus CCT, so dual white, you can easily do that with this board and be done with it. But what if you want to run something? There is a spot for a temperature sensor there, but the Mini, just to save costs, won't have it by default. I won't remove any of the circuitry or anything like that, so you could definitely solder it on there yourself if you're capable, because these are quite small pads, but it won't have it by default just to save cost. If you're buying like, 50 or 100, I could maybe in a production run have them added, but not for a singular board, because that would just become too expensive. But yeah, those temperature sensors are like $1 a piece, and yeah. So to save costs, to make this a cheaper board, some stuff had to go. Right, so that's the AN Mini. We'll be working on that because I have 3 boards here from the pre-production run, and we use the new production house or assembly house, and they kind of screwed things up. So we're going to need to fix the ESP32 soldering job on there to make it work. And I have one that's still in the back that still needs fixing, so we'll be taking a look at that and then testing it. Right? So that's the AN Mini that's coming. That's going to be, I think, the most popular product to just run some good, decent analog strips. If you want to run a few white channels, but don't exceed 2 times 5 amps, or you want to run RGB plus some white, or RGB plus CCT, etc., you can make all those combinations here, and that'll run great. I'm going to continue with the boards, and then I'll answer the questions in chat. So the next board, and I need a plug real quick, is basically its bigger brother. No, that's the wrong one. That's this one. So this one, as you can see, it also is already bodged. It came with SMD fuses, but those weren't going to work either. They're limited to 24 volt or they're limited to 60 volt, but then 1 amp only, which, you know, isn't going to be a lot either. So I already did some bodge work here and testing and things like that. But speaking of the board, this one is based on a normal ESP32. It again has a I2C connector. It has USB-C for programming, including the serial programmer and things like that. This one has 2 beefy input terminals, because this board can take up to about 45 amps in total. Again, in the end version, it should be up to 48 volt. It has lots of capacitors. It actually has 2 dedicated buck converter circuits, which are making the voltages for the ESP, but also making 10 volts to run the gate drivers. On the AN Mini, it just made 5 volt. So we're driving it even with a higher voltage. And then we have 15 output channels. So basically, you could see this as an AN Mini, which has 5 channels, but this one has 3 times 5 channels, so 15 channels. And that is great for if you want to run multiple RGB strips or RGB CCT strips, or you want to run 15 individual white bars or something like that that don't use too much power individually. This board is going to be great for that. It has 6 times 7.5 amp on the outputs once we fix this fusing issue here. And then it has 3 times 5 channels, as you can see over here. All of those are driven through MOSFET gate drivers, so they're going to be relatively efficient, although the MOSFETs are still fairly small. And yeah, so this is if you want to run much more channels. All of them will come with external Wi-Fi, so no integrated Wi-Fi antenna. You'll always have a good reception. And the idea is that all of these boards in the end will be in a metal case. I think, yeah, I have an example of that here. I guess I can show you now. Let's try that out if it fits. I actually haven't tested this board yet if it fits. So I need to move the antenna here to something like this. And then I should be able to slide this in here. Nope. There. Oh, let me zoom out a little bit. Now this is all still being worked on, so don't pin me on that. And well, this isn't going to fit. We're still finding a solution for that too. So for now, I'm just going to bend these down. Probably not enough. Nope, still not enough. Oh yeah, there's a capacitor here. Oh geez. Okay, yeah. So this still needs a better solution. We're working on that. But I think I should be able to close it now. Maybe not. Let's see about that. Yep, it's closed. So in the end, it will be in a metal housing. You'll have the input ports. Of course, we need to have a cutout here for the connectors and things like that. Let me try that again. There. And then the output connectors will all stick out, and it'll have a nice faceplate and some printing on the top and things like that. So let's move the case away because we're not going to be using that today. So this was just to demonstrate that in the end, all products will come in their own aluminium case. That's the idea. So these aren't going to be bare boards. These are more going to be, you know, a product you can actually use. And as I said, 5 times output, 2 times positive, 5 times output, 2 times positive, 5 times output, 2 times positive. For if you want to run 3 times RGB CCT. But also, each of these channels can do 3 amps by themselves. So if you wanted to run 15 white strips, etc., that would be fine too. Right? That's basically this. This is a bigger AN Mini. And then we have a last board. I don't think such a PSU would be cheap either, there, Earth Gamer. Okay, so, well, the last board, and I already saw it in the chat, this is the AN Hybrid Hexa. Still a work in progress there. This one also has an ESP32, external antenna, USB-C, programming, etc. But it has Ethernet. Like you guys were asking, it still has I2C, it still has the 2 dedicated buck converter circuits, and it has 4 inputs here. 3 are for buttons, 1 is free to use, 3.3 volt and ground, or I believe there's actually 2 grounds because I had room. So you can connect all kinds of buttons, rotary encoders, and other stuff. It again has fusing for all positive output channels, and this one has 5 analog outputs. So as you can see here, but they are using bigger MOSFETs. So this can support 3 amp per channel or so, I'd recommend. And this one can support up to 10 amps per channel. So if you want to run 10 meters of 28 watt meter per watt per meter, Jesus, LED strip, you can do that with this guy. And it's actually specially designed for that because you have a single MOSFET here, and then you have 2 output channels that are linked to that MOSFET and 2 positive channels, each fused at 7.5 amps. So you have 15 amps in this plug, 15 amps in that plug, and then we still have 3 extra channels here, which are also fully level shifted, gate driven with 10 volt and specific gate drivers. This one actually uses very high powered gate drivers. So you can still do RGB CCT, or you can connect lots of high power LED strip. But then it also has something special. It has this connector over here, which is basically an output of the voltage that's coming in, and a loopback connector so you can connect a buck converter, and then it has a digital output over here with level shifter, etc., like you're used to. So you could run 24 volt LED strip and then run 5 volt, 12 volt, or 24 volt digital LED strip too. So that's why this is more of a hybrid version. You could run warm white and cold white LED strips for where you want those, and then still have a fun RGB, addressable RGB strip for when you want to do effects. And it can be the same voltage, so you can have 24 volt analog strips and a 24 volt digital strip. Or if you use the converter plug with a little external buck converter, and we tested those like 10 live streams ago, you can use a 24 volt to 12 or 5 volt buck converter and then run 5 volt digitally addressable LED strip, all from the same controller. So yeah, so this again only has 5 analog channels, but then adds Ethernet, adds a digital channel, and things like that. So it's again a very different configuration, but these 3 configurations are what I came up with. Like, okay, if I wanted to use analog controllers, what features would I want? And you could say, but I want Ethernet and 15 output channels. Yeah, the problem is the ESP32 can't support that. There's just not enough pins, basically. So I had to make compromises there. There's not one board that does it all, but there are 3 boards that are very specific in their function and, well, usable in certain places. For this one, I haven't figured that out yet, Emil. I first need to see in what volume we can produce them, how much the components will be, assembly, testing, things like that. But yeah, as with all my other products, they shouldn't be too expensive. But yeah, yeah. So this one is if you want to run a few white strips or RGB plus some white strips or RGB plus Ethernet or digital, whatever, and want to have Ethernet, you can use this guy, and that should work fine. I'll think about it, Emil. So that is the three 3 boards that exist now. These 2 are actually exactly the same size. That works out nice in regards to housing and things like that. And the AN Mini, well, it's its own size. But yeah. So this was, as I said, this whole video is a secret. This is basically a first introduction to the analog boards that are coming. All of this will be compatible with ESP Home. Most of it should also be compatible with WLED, and that will give you lots of different various scenarios that you can use them with. And yeah. Cool. Well, in theory, I'm going to sell them always with an enclosure with them, because they're more of a product than DIY. But you can always take them out and use them in your own enclosure. There's no mounting holes though, but yeah. When ready, instant buy. Thanks, that's awesome. Yeah, this is mainly for people like me who run Home Assistant and want native integration of LED strips and things like that, and don't want to mess with Zigbee or other weird standards. You know, just connect it over Wi-Fi and done. Right, so these are all pre-production boards. So basically the design is mostly finished, and we run them through production to see what issues pop up. And it's a good thing we did so. Because, well, there were some issues. That's for sure. Let me get one of those 15-channel ones. Or, well, I guess we can pick which one we're going to fix. Let me see which ones I have here. No. Yes. I need this box. Ooh, the Zigbee. Yeah, I like ooh the wireless. And maybe I'll make a Zigbee version of the AN Mini at some point, but I'm not sure about that. So these are literally fresh in the bag, as you can see. Is it open? No, it's not open. No, they're sealed. Yeah, so these are literally, I have not touched them yet. I did touch the other ones, of course, but yeah. So let's run them to the test and see if they work, or maybe what's wrong with them, and then see if we can fix that. Because it's either a design issue, then I made a fault, or I did bad, or it's an assembly issue, and then I need to instruct the factory to do things differently. Well, since you guys all love Ethernet so much... Oh, these are 2 of the same. Hold on. We can work on the Ethernet version first. That's fine. Yeah. So we need that one. Sure. We can always do custom things with AllNet. That's no problem. So if you want to buy 5 or 10, we can always, you know, look into something custom. I'll look into DIN mounts for them. I can probably have those created too. Yeah, that's all fine. So let's start with the Ethernet version then, since people seem most interested in that. I don't have my scissors here, so we're going to use this guy. There. Darcy, so the 15-channel one is a little less per channel. Per channel, it can do about 3 amps. It'll do, in the end version, it should do up to 48 volts. So 24-volt LED strip would be fine. Right? The other one, the 5-channel one with Ethernet, that one can do 10 amps per channel if you want to run the really high power stuff. And it's also designed, so that's basically this one, it's also designed to have multiple outputs for a single MOSFET. So you can run, for instance, 10 meter with power injection wires from a single MOSFET. So, yeah. What are they asking? Have you ever thought about a line of boards with sensors or connectors to make it modular for ESP Home? I have, actually, and it's called Plan Next Year, but it's from 2 years ago now, or 1.5 years, I guess. But I decided to keep my focus on LEDs for now, and it was a wired system, not wireless. Maybe I'll pick it up again in the future, but these boards are also expandable if you want to, because this connector here is a Stemma QT connector, and you can connect anything I2C you want to it. So if you have a sensor, a different type of sensor, but it's I2C compatible, you can just plug it into the board, configure it in ESP Home, done. But maybe in the future I'll think more about it. But yeah, we'll see. Yeah, if you look at this board, this is really lots of custom design here. Anyway, let's hook this board up and configure it and then test it. So we have, let's see here. First we need plugs, I guess. I'll have to steal them from the other board. There. And I've already written configs for most of these boards, or at least testing configs. So we'll probably botch those. This is a 3-pin. I still need to figure out if they can make me a custom connector that has green on this side and then red. They're orange right now because I still had orange. Red on that side, because this one has shared negative and positive here, because I really like that look. If you look at the 15-channel board, I had enough space to use separate terminals. This makes it very clear what is positive, right, and what is negative. So yeah, downside is these are 5.08 millimeter and these are 3.81 millimeter. Still, that I believe that will work out fine. Well, I don't know yet. I really have to sit down to calculate the price. They're not going to be insanely expensive, so between 20 and 40 bucks. So like the AN Mini, I'd like to target 20 bucks, but I don't know if I'm going to be able to make that. But then it would be like $24.99, so like 25 bucks, right, for the Mini. The 15-channel one, probably around 30, 35, and for this guy, maybe the same. I have to see. Something like that. But it could be upward of 40 bucks, but it could also be a bit lower. But to give you some kind of estimate, you need to think about those kind of prices. But I need to see, because I need to make a few bucks of profit if I do have to do a replacement or something like that. Yeah. But, you know, I don't try to price myself out of the market. Let me prepare my browser real quick. Oh, the King Coney, is it expensive? Oh, you're building some AN Pentas there, Lawrence, and it's not going well? Check in the Discord. We can always try and help out. But yeah, time-wise, it'll likely be, I don't know, let's say 2 months, right? Because we still need to do pre-production testing. Then we need to make adjustments. We're working on the casing deals in regards to components. So the BOM, we're working on casing documentation, there's still lots of stuff that needs to be done. So at least 2 months. 200 plus. Oh, wow. Okay. Yeah, no, that's not what I'm looking at for pricing. As I said, I hope that I'll top out maybe at $40, and I really hope to be able to do it cheaper. So, yeah. Let me fix my browser real quick. I lowered my camera for today, and now it's kind of in my face. Let's see here. In theory, this will work. Yeah, need to resize a little bit. There. Now, let's hope we're not going to encounter any passwords. I'm going to check that real quick, actually. So I'm going to put you guys back on the big screen and see if I have any stupid passwords in my example configurations. I shouldn't have, but I think I do. Okay. That should do it. Let's move this down a little bit. And now you should be able to see the web browser. So the first thing we need to do is we need to flash some kind of firmware on here. And since we're going to use Ethernet, that's going to be easy. We're just going to use a static IP. And then I should be able to easily configure and use this. So let's... oh wait, I don't think I have that camera enabled. Oh no. There. Let's plug it up with Ethernet already. There. And I need to go into my configuration for the pre-prod AN hybrid 1. We'll make a pre-prod AN hybrid 2. So let's make a new device. We'll do this later because we do need to use the ESP Home Web. So this is going to be oh god, I can't read it anymore. Okay, hold on. There. Pre-prod AN hybrid 2. I don't need recommended settings, and I don't need that either. I don't need this. I can skip that, and let's just edit it. This can go, all can go away. And I'm just going to paste this in here, because this is the config. And I'll run with you through the config real quick. We're using an ESP home name, pre-prod AN hybrid 2, because this is the hybrid hexa. I'm defining the ESP home name and defining the ESP32 board. We're not using the ISP IDF. We can also, I sometimes switch between that just to test it out. And I'm defining the Ethernet here. Fine, I think. We'll see. We don't need a power pin in this case. We want the web server. We don't need any logging. We have I2C, so that is for the onboard temperature sensor. And the I2C plug over here, which we can connect anything else. I2C. We want to have an API, and we have a password here, which is no hacking here. But that's just on my test Home Assistant. This is a separate Home Assistant installed just for testing. So good luck with that. We want some time. Then we have a switch, which is a switch I get in Home Assistant so I can reboot the board. Oh, are you getting lag? Then I have another switch, which is actually a MOSFET, which is acting as a relay circuit for the digital RGB output, so the power output. We'll take a look at that in a minute. Then I have my... oh, I lagged a bit. Okay. It's fine now. Okay. Thanks for noticing. Oh. Then we have our outputs. We have 5 analog outputs, which are running at 19,531 hertz. So about 20 kilohertz. So we shouldn't see any flickering or anything like that, even on camera. And then we basically define those lights, and I use the name of the board and then the 5 output channels. Oh, we have a fade length of 10 seconds. That's a bit much. Let's make that 3 seconds. We'll use 3 seconds to fade between value A and value B. Is it dying? Oh, I did have dropped frames. Why did I have dropped frames? Oh no. The dropped frames are back. Okay, I'll wait a little bit. Okay, if you had lag, maybe hit refresh. So you refresh your browser and then it should catch up. Yeah, I see I had 707 dropped frames, but I have no clue from what. Zigo just heard you switch providers. Uh-huh. Okay, well, let's hope everyone is catched up now. So we'll continue with the configuration. We just defined the 5 analog outputs in the light. And then I'm defining another light, which is using the same outputs just for testing, which uses LED channel 1, 2, 3, and 4, and 5 as an RGB WW, so RGB CCT. I don't like the RGB WW name, but yeah. Okay, and then we're defining a NeoPixel bus when you plugged in that board. Oh, interesting. Huh. Well, it is in the same switch, but this board isn't on, so in theory it shouldn't do anything. Well, we'll see when it turns on. So, NeoPixel bus we're going to be using for the digital output, so we can test that too. Then we're defining a sensor. This is a SHT30, I believe. So we're defining, yeah, SHT30, so we're defining that temperature. I'd like an uptime temperature sensor too, so we can see that in Home Assistant. Then we have a binary sensor, which is for the 4 button outputs, or inputs rather. And, well, that's it. Right? So let's save that, hit install, and now we need to do manual download. We want to open this guy, open ESP Home Web in a different tab, there. And then we're going to use the modern format, so that should compile real quick. Now, let me turn on one of my USB ports here. This turns on my... oh, I'm not sure I can actually get that on screen. It's not long enough. No! Okay, let me try a different USB port. See if that's longer. I can't get it on screen. Okay, well, I'll have to zoom out. While it's compiling, we can check that out. Okay, I can somewhat get it on screen. There. The USB... Oh, I can just take a longer USB cable. Hold on. Or I can get another USB extension cable. That's it. That's always good, right? Having multiple USB extension cables, like, connected into each other, that should work great. There. Now I can also use the first port again. Disable this port. There. Meanwhile, it's still compiling. That's fine. Oh, no, it's done. It's done. Okay. Okay. So, we have a USB tester here. And what that does, or why I want this tester here right now, is because this is the first time we're plugging in this board. So it's going to be interesting to see how much power it's going to use. Because if it uses an insane amount of power once we plug it in, we already know something is wrong. So we should see or hear, but I guess you guys won't hear that, a device pop up in Windows. And it should draw, well, maybe a watt or something like that, but not much more. Maybe half a watt even. So, are we still there, chat? Because it's been quiet in the chat. I hope people are still here. I'll wait just a second before plugging it in. Oh, yeah, okay. Everybody was just quietly watching. Okay, that's fine. That's fine. Still here. Good. So, we're going to be plugging this in while we keep an eye out on this power meter here to see if we don't get a very high power draw to start with, right? So, let's do that. Okay, I heard the ding ding, and we're drawing 1.2 amps, or sorry, 0.2 amps or 0.6 watts. That should be fine. That's okay. Okay, so we're going to be, so that's the first test passed. We have a single orange LED here. The orange LED, because I designed it, I know is from the buck converter circuit that will convert to 3.3 volt, because there's no LDO on this board. So the ESP should also be powered. Let's go to Chrome, and let's see the second tab here. We have to use this website because the web flasher of ESP Home needs HTTPS, and my test Home Assistant isn't HTTPS and blah blah blah. They have a workaround for that using this website. So now I can just hit connect. I get a pop-up. You guys don't see that. I can connect my COM3. So connect. Then I can say install, and we can download the file we just compiled. So that's preprod AN hybrid factory 2. So that's over here. Oh, wait. No. And now I should be able to hit install, and hopefully it'll start erasing the ESP and flashing it. Okay. That's already good. Something is happening. I guess I know you guys are waiting for magic smoke, but I'd rather not see it. So flashing takes a minute or two. Oh wow, it's really using very little power right now. Okay, flashing was successful. Seems to be booting. Oh, it's using more power now. That's actually a good thing, because one of the things that happened is that our Ethernet light lit up and it's happily flashing away. Well, that's a good sign. Right? So, So far so good, because that basically verifies the ESP32 is alive and it's communicating with my LAN chip, and the LAN chip has a connection to my network. Oh, this is, I have several of these meters. Oh, wait, well, I'm going to disconnect this one for now. Hold on. This is a Wittern U2, but you can get all kinds of variations on AliExpress from $10 to 50 or even $80, depending on what you need. Most of them also let data through, like this one, so that's good. So right now the board was online and we had Ethernet. That's good. The next step is, well, let's connect power and see if it blows up. Right? So we connected these fork style terminals, or crimps, to make it easier to connect to these. You can still use wire ferrules too, those will fit. But I like using these fork style, especially for higher power boards. And this can do up to 30 amps or so, so I consider that higher power. Now, there's not enough labeling on the board yet and things like that, but in theory, most people would use these boards inside of a case, and then the case will have the labeling. But I'll also add some labeling on the board just to be sure. But I know what is positive and negative in this case, so. Okay, that should be nice and secure. This is connected directly to my UHP 500-24, so this can deliver 500 watts. So we need to be a little bit careful with that. Once we plug it in, that it's not going to use an insane amount of power. Because if it does, well, that would be bad. Because there's no LED strips plugged in. So I have a power meter in my socket here. I can't really show you. Yeah, pluggable would be better, but I've been testing with pluggable versions. Actually, the previous prototype had a pluggable version, as you can see here. So this is a manual prototype of the same board I built before we did pre-production, of course. As you can see on all the black soot and everything else. And it had extra features which have since been removed. And well, anyway, this is a manually built prototype. So I had a pluggable connector there. But then you can't use the fork style terminals. And with this type of terminal, you can still use wire ferrules without a problem. But on this guy, you can't use fork. So this allows more options. And it's basically the same as having a DIG quad or a DIG octa, etc. So I'd like to use this type of cable connection standard because I really like forks because they're just a better connection in my opinion. So I did test with a pluggable style connector. Another problem, this connector plus a plug, $2.50. This guy, 20 cents. I mean, and then if we're talking this guy, just the component cost alone, since I need two, would be $5 for two connectors, or 40 cents. Yeah. So I decided against that, and I moved away from the pluggable connector for that. Yeah, the downside, I'll have to do some machining on the case, but that shouldn't be too big of a problem. These cases also aren't final yet. These are example cases, so yeah. Oh, Rick, that's a good question there. Dig Uno, but if it, I have to switch to Dutch for a minute, guys. Hold on. Of die ook werkt met de Homey van Atom. Dat is een goede vraag. Als de Homey WLED ondersteuning heeft, dan gaat een Dig Uno prima werken. Dus het gaat er niet zozeer om dat hij Dig Uno ondersteuning moet hebben, maar meer de software die op de Dig Uno draait. En dat is in de meeste gevallen WLED. Dus je zou even moeten kijken of een Atom of een Homey WLED aan kan. In principe. How about a Pro line and more profit for you? Well, this has already high quality components. I don't skimp on components even if it's more of a consumer product or whatever. It would maybe differentiate in regards to features, but I think with the 3 boards, it's already pretty usable in a Pro setup. But what kind of feature would you change? I mean, yeah. Sure, no problem, Rick. Anyway, so we now hooked up the power leads. The next test is, well, we don't have to do anything with fuses because these are the fuses. They're auto reset fuses. New flams. Yeah, I don't know about that, man. I'm going to enable the power supply and watch the output. If it's very high, I'll quickly turn it off. If it's normal, well, I'll leave it running. So this is the point where I put on my safety glasses, because this was 5 volt at 1 amp PTC protected, or whatever. Even if it would dead short circuit, there would be no problem because there's all kinds of protections in place. All the circuits are protected too, but if there is a problem here with the MOSFETs, it could draw, I don't know, 10 amps or something like that. And at 24 volts, that could certainly cause issues. While here at 5 volts and limited to 1 amp, yeah, not that much. So, let's turn it on. Oh, wow. Okay. I did see pretty high current there. It spiked about 15 watts real quick, and now it's down to 3. So I think it's probably all the capacitors I have on here that filled itself up, and now it's settled down. And Ethernet's working again. So at least the ESP booted in that sense. Now we can also see that we have an orange LED here, same as we had with the 5 volt input. So that's good. That's the 3.3 volt for the ESP. But we also have a green LED here, and that is the secondary buck converter, which is making 10 volts for the MOSFET gate drivers. First time I heard you speaking Dutch, I can actually do it. Who would have thought? Okay, so that all seems fine. I don't think there's any... Well, the next test I guess I should do is see if there's any heat. But I need to get my thermal camera for that. Hold on. I was working on stuff in the garage, so some of the stuff isn't here. Okay, let's see here. Don't leave the bomb unattended. Okay, I need to fix some stuff here. Okay, let's go to RGB. No, what? IR, yeah. So if we look at the thermal camera, we see a hotspot over here. But that's normal. That's the Ethernet chip, and the Ethernet chip has an internal regulator inside of it, which will generate a little bit of heat. But it's 37 degrees. That's fine. That's no problem. Okay. The rest of the board seems pretty cool. Yeah, probably touch it there. Yeah, so this part of the board is heating up. But that's just the ground plane soaking away the heat from the Ethernet controller. And maybe a little bit the buck converter over here. But... yeah, it's 30 degrees. That's not really that hot. So that all seems good. Keep talking or it explodes. Yeah. So let's see if I can find it in my Home Assistant test install. It should just pop up, but let me check that real quick. And it doesn't. Let me troubleshoot for just a second here. Does it have an IP? No, it doesn't. Interesting. It is happily blinking away. Oh, wait. Okay, you guys can see. So in my configuration, I said use address 101. But use address isn't a static IP. It's just telling ESP Home to use that address to connect. Because it actually got a different IP. And let me connect it out real quick. Hold on. There. It actually got a different IP. So I just need to change the configuration real quick and then it should work. So this is our pre-prod AN Hybrid 2 and connected to its own internal web server in ESP Home. That seems to be running great. So that's good. Yeah, it's sending some stuff. Okay. So I need to change the configuration to say 106. Save, install, and let's just install that wirelessly. It should work. Was there a hotspot next to the USB? I don't think so. Hold on. Okay, it uploaded the new firmware over Ethernet. That's good. Oh, that is interesting. Why is this chip getting hot? Wait, well, let me show you. So this chip over here, this tiny one over here, is getting hot. It's 43 degrees. That shouldn't be happening. I don't think. Okay, let me inspect if there's maybe a soldering issue there. No, that looks perfectly fine. That's interesting. Now it's gone. So right now, there was a hotspot over there, but now it's gone. That's odd. Well, then I'm interested in if USB is still working, because this little chip over here is my USB ESD protection. So, in theory, it's designed so that even though I have the 24 volt power supply connected, I can still connect USB. So let's see. Okay, let's try it without power, just to be sure. Okay, it's off. It's not working anymore. How interesting. I think it did just die. Because we can clearly see the USB is working, because it's getting power, because otherwise the Ethernet wouldn't be on. But I think it did just die. No, it didn't do its protection work. Because it is enumerating a USB device, but it's like non-descriptive. It doesn't know what to do with it. I'm not getting a COM port anymore. What the? Let me check on another board. Hold on. So this is the board I tested with before. No, it's all USB-C. What is going on? So this is not working either. Well, this shouldn't work either because it's the same circuit. And it doesn't. But that feels wrong. What's going on? Yeah, I think this is Windows. Hold on. I tested with this many times. Oh wait, I did add an extension cable, didn't I? Yeah, hold on. Let's try it without the extension cable. Still nothing. Yeah, I am using a USB hub, yeah. And I can see the power draw, so that shouldn't be it. I am confused. Oh! Yeah, no, it failed again. Power draw is 0.7 watts, so that isn't it. Nope, unrecognized. Interesting. Let's try a little AN Mini here. Okay, so that immediately connects COM4, no problem. Okay. And then let's try my previous hybrid. Nothing. That is confusing. Try restarting the hub. Well, I just connected something else and that worked fine. But I'll try it. Hold on. Okay, reconnecting the hub. There. Let's try it now. Nope, unrecognized. And one of the previous boards. Nothing. Huh. That is interesting. No, it shouldn't. That's all not connected together, so... Interesting. There might actually be a problem with the circuit. Because, well, we all saw this worked. It has firmware on there. But it's now dead? Yep, USB device not recognized. Interesting. Yeah, but sure, I get that. But I've been playing with these boards for a week now, and this is the first time I've ever seen that. And I've been running them on power and dual connected and everything. So I'm a bit confused, but let's turn on power while we're watching it. Okay, Ethernet's working again. And there's a little spike here on the DC-DC converter, 31 degrees. So that's fine. And now there's nothing over here. Let's try connecting USB while it's on. Nope, unrecognized. Interesting. I have no idea. That shouldn't have happened. Well, I think the first thing we're going to try and bodge on here is replacing that little ESD chip and then see if that fixes the issue. No, but all these three boards I showed you initially, I've been working on last week with main power and USB and everything, and flashing it for 40 times over USB without a single issue. So that's very odd. Anyway, let's first do our tests to see what else is or isn't working, and then let's try and fix that to see if it's a schematic issue, or a PCB layout issue, so something I did, or maybe an assembly issue, or a broken chip. No, I don't think there's anything shorting out here. There's no context on the bottom anyway, just from the through holes, so yeah. It could, of course, been ESD from my mat. Anyway, let me configure Home Assistant real quick. Because I know there's already other issues with this board. Anyway, let's see if we can now view the logs. Now that we changed that IP, we should be able to. Yes. Okay. Because there's multiple issues here we're probably going to have to fix, and I already knew this. As you can see here, when it boots, it tries to open the I2C bus, and it fails. Okay. Now this is a problem I already diagnosed on one of the other boards. And basically, for some reason, all the temperature sensors are broken when they came from assembly. But I tried this on one of the other boards already I was testing, and I replaced the temperature sensor, and after that it worked fine, and it kept working fine. So that's one of the things we need to check. Maybe they somehow damaged the ESD chip too. I don't know. So I2C has an issue, so we can't see the temperature sensor, right? But it seems all the analog channels are there. Okay. Well, it can't connect to the temperature sensor. Ethernet's working. Okay. So next thing we should do is we should add it to Home Assistant, and we'll do that just by the IP. Oh. Okay. And hybrid 2. And there we go. This is all our devices. So we have our analog channels. So this is 1, I don't know, 4, etc. We have our NeoPixel lights. So that's for our addressable LEDs. We have our living room lights. That's basically what the RGB CCT for the analog channels is called. So all of the channels, so we can mix and match a little bit. And then we have our digital RGB power control. And that is actually the first thing we can test. Because if you take a look at the board here, and I flip that control, there should be a blue light that turns on and off. Okay, that seems to be working fine. That is basically the relay circuit for the digital RGB lights, or the digital addressable LEDs we can connect later. So that seems to be working. Okay, so let's connect some LEDs and then see how that works, right? I have some... Oh no, did I mix them? No. Let's see here. I have some cob CCT strip. So this is dual color white. And then I have some cob RGB strip. So 3 colors. Let's connect that and see if all the output channels are working. See if the board even does what it's designed for, basically. Okay. So this one has a single positive. So let's connect that over here. And then it has dual white. Now this isn't a very high power strip, so it doesn't need 2 outputs from the same MOSFET. So we're going to use this one for neutral white. Or cold white, probably. Let's use this one there. And then we're going to use the other MOSFET, which is this output over here. Now, as I mentioned before, each MOSFET of these has 2 outputs, so you can run very high power strip over the same MOSFET. Okay, now that's connected. Positive, dual negative. Easy. Let's put that over here, I guess. I don't know. And then we have our RGB strip. For some reason they use black. I don't know why they do that. It has also a positive, so let's use one of the other positive outputs. Doesn't matter which one, because we're not going to use that much power. And then it has red, green, and blue wires. So let's connect those to the RGB here. Come on. Okay. Yep. Cut the red wire before it's too late. Yeah. Okay. Yeah, I don't know. I always find black confusing, but you know. So right now we have cold white, warm white, blue, green, red, right? And let's also connect some RGB strip or some addressable strip. Hold on. And for that, we're going to use my favorite, the addressable RGB neon. So we'll need a little, you know, a little plug like that. And I'm going to, we're not going to have to change the voltage because this is also 24 volt addressable LED strip. We'll test the buck converter stuff later. So we need a positive 24 volt output. That is this one. And in the final product, it'll have labels on the board, so it'll make it easier to know where to connect everything. And these need to go over here. What is ground? Yeah, I think this is correct. Okay, so we have a positive, a data, and a negative connected. And let's connect that to this strip over here, which is, as I mentioned, is also 24 volt. Let's move this down a little bit. So everything is on screen there. And I won't show you the Home Assistant screen because you've seen that before. So let's turn that on and let's hope it doesn't blow up. Nope, didn't blow up. That's always good. Another thing you might note, no flickering. That's because I made very sure to use GPIO pins which didn't flicker, but you know. Okay, let's just test channel 1. Okay, channel 1 seems to be red. That's good. This is 100%. Let's turn it off again. Channel 2. That's green. That works. Oh, that's really bright. And blue. Yeah, that certainly works. 23 watts. Okay, cool. I don't know if it'll be damaged by the negative outputs, but if you put 24 volt on the data pin, positive for sure. Okay, let's test. The first white is seemingly cold white. Okay, that's drawing 50 watt. Ow, ow. Okay, and the warm white. Yeah, that works too. Also 50 watt. Wow, that completely blows out the camera. Okay, so that was a fade in and a fade out. So we basically know that dimming and PWM and everything else like that is working. Let's test the digital light. So if I go to the NeoPixel and I turn it on, let's say to 100%, and I set a color like, I don't know, do red, it doesn't do anything. The reason for that is because the relay is basically still off. So if I flip this digital RGB power relay here, bam, it instantly gets power and it works. Oh, did I get a white version? Oh, I might have gotten a white version. Hold on. Yeah, I did. Okay, that's not gonna work. Hold on. I need a RGB one. Oh, okay. Yes. Okay. Okay, let's connect that. Oh, this is a new one. Okay, that's fine. Okay, let's check that again. NeoPixel thingy. Okay, so the color order is wrong. But we should be able to do red, blue. Okay, blue is right. Okay, red and green are reversed, but that's not too big of a problem. Let's see if we can do an effect. Yep. I should have a different rainbow too. There. That's a better rainbow. There. Let me turn that down a little bit. Okay. So now we can see we have the digital RGB. I'll explain why button 4 is on later. And we should be able to use the living room lights, which are all the analogs together. to do all kinds of colors and things like that. So let me explain that a little bit. So this is an RGB CCT instance in Home Assistant run through this board. So then you can control the cold brightness, the warm brightness, or well, in reverse in this case. Oh wait, well, so let's up the color. Now we should be getting blue, green, red, or anything, you know, in between. But we can also control the cold, which, yeah, cold white, and we can control the warm white separately. Okay? And it's a bit dim now because I dimmed it down because, holy shit, it's using 100 watts of power already. And I can put this on a very fast random stuff too. This is basically what I use in test mode. I have programmed it so that Analog changes its intensity and its color every second, and I just let the RGB, the digital, do some kind of pattern or something like that. So this is now changing very quickly. The only thing it doesn't change is the brightness. I can put it up at 100%, but then, well, yeah, it's very bright. Let's see what it spikes to. It doesn't even show up on camera anymore. It's just all blown out. Let's see. Oh, wait. It's doing that thing again. There. Yeah, so now it's just doing random patterns, and during testing I'll leave this for 24 or 48 hours to see if nothing heats up on the board and everything's working correctly. Let's take a quick look at that. So the difference between digital and analog strip is in homes for primary lighting, analog is basically still king because it has a much higher CRI and it's easier to control in a certain sense, but mainly because digital RGB can't be used for primary lighting where analog white certainly can. So that's basically the main difference. So you can use this for primary lighting. Looking at the board, the Ethernet chip is still warm, but nothing else is. Nope. So that seems to be working just fine. And it's all working together, right? I mean, yeah, seems to be working great. Now someone said turn on, let's turn this light off there. Turn on both CCTs, okay? And I think you probably mean 100%. Now that doesn't draw double the power because the plus wire, so the positive wire is shared, and there's just not enough copper on the positive side. I'm gonna shield that a little bit. But it's currently drawing 92 watts. So let's max out the this one too, and let's set it to none, and then let's set it to white. It's now drawing 183 watts. Holy shit. It's quite bright. Oh wait, RGB is still off. Hold on, we can draw more power. More power. Let's do it. Go, go, go. Oh yeah. Oh, now it's drawing 247 watts. No. And I don't think the board is actually heating up. But the LED strips certainly are, especially on this roll here. Well, let's quickly check if the board is heating up at all. I have other strips for power testing here. I can't even see. Hold on. So some of the PTCs are heating up slightly because, well, there's power running through it. That's normal. Let's move this out of the way real quick. The imprint of the LED strip on my desk is still there. Yeah, the Ethernet chip's still warmest, and that is, I can't even see. Hold on. 40 degrees, that's fine. Oh, there's a MOSFET heating up here. That is 37 degrees. I don't think that's a problem. Oh, you can see it right there. 37, 38. Yeah, that's not a problem. I'm going to turn this off before stuff starts melting. There. Ow! Ow, it's hot. Holy shit, that's hot. Okay. Oh, yeah. Oh, oops. This is why you should never do that. Can you see that? It's already started warping. So let's unroll that quickly. Ow, 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 ow. Ow, that's hot. No. This is 48 volt max there, Emil. But we're running with 24 volt strip currently. Yes, that is true. So this also has already warped slightly. So there's a lot of heat here. So let's get that to cool down a little bit. Well, we have stuff that isn't working, but we have other stuff that is working. As long as it doesn't stick together, it's good. Yeah, I don't know about that. So our temperature sensor isn't working. Now I've diagnosed that problem before. And those are dead temperature sensor chips from assembly. I don't know why. I just know it happens, so we're discussing that with them. Maybe they used it too high temperature or something like that. Wrong profile. And our ESD chip died for some reason. Let's plug it in again, see if it works now. Who knows? Nope, unrecognized device. Well, yeah, but you can also run 48 volt strip. So yeah, that all seems to be working great. One of the features I want to show you is if I turn on the RGB and I set it to a pattern there. So now it's doing all kinds of, blinky stuff. No, Jonathan, the Oxmer is still the best brand I recommend. I am working on some custom strip for 48 volt, which will be decent CRI. There won't be CRI 95, but still. But yeah, what I recommend on my website is still the best, in my opinion. So we have a digital RGB pattern going on here. Let's try flipping that power switch. Yep, that works. So now, as you can see here, the blue LED is off. That means the positive output to the digital LED strip is switched off, so we don't have any idle power usage. And we can flip it on again, and it instantly starts and works. So you could say, well, no, this isn't the first Quinled board that has a built-in relay. The Dig2Go has this too. Cool. Okay, let's turn that all off. I guess another test we could do is, let's set this to 40%, and let's set this one to, I don't know, 34%. Do we see any flickering? We shouldn't, because this is running almost 20 kilohertz. But you know, uh-oh, did the stream lag again? I didn't have any dropped frames. Yes, it's a MOSFET, but it's a bit more complicated circuit. But yeah, in the end, it's a MOSFET doing it. I think it's better because there's no moving parts and it's a lot smaller. It will be a little bit less efficient in theory, but if you design it correctly, stream very choppy. Okay. I'm not seeing any issues. MOSFETs are very solid. Maybe it's a Dutch YouTube crash. Okay, so yeah, it is a MOSFET, but this LED strip, and that's also an advantage of digital LED strip. This LED strip is PWMing at 20 kilohertz now, and well, you even the camera can't see any of that. It's just perfectly fine. This red one too. If we did the same thing with the digital strip, we would be able to see some PWM there. So let me raise my no, not that one. Raise my shutter speed. Okay, we now have a shutter speed of 1000. Okay, let's turn on the digital strip and set it to green, I think then. Yeah. Okay. If you look at the digital LED strip, let's set it to 60%. There. You can clearly see that there's some weird PWM pattern going on there, right? If we take a look at the analog strip, however, that is perfectly solid, like it's just meant to be that way. So that is also a difference between analog and digital. This board can run probably safely up to 120,000 kilohertz, or 120 kilohertz, while this stuff runs around 1 kilohertz, as you can see here. So that is also, if you want to use this in a studio with photography or video or something like that, all my lights here are analog LED lights because I can run them high enough frequency so that the camera doesn't pick it up when I use them. As you can see here, this is all perfectly stable and no problem, even while it's dimmed down. So let's show you that. Let's go to, I don't know, 70%. Or let's go to 20%. Right? It's perfectly stable. No PWM artifacts whatsoever. And digital, well, you're going to run into that problem because you can't influence the PWM rate the chip runs at in those LEDs. So if you're using this on video, you're going to have an issue. Or you're going to have to do a lot of adjusting to your video recording to not see it, basically. And this is one of the most modern LED strips out there. So, yeah. Now let's see if anything heats up when I'm doing that, when I'm having low power. Don't think so, but... Okay, that's still the Ethernet chip, 40 degrees, that's fine. And the buck converter. Those hotspots are reflections. Oh, okay, I need to lower my... Yep, that's fine. The P channel is getting slightly hot, I think. It's 32 degrees. That's fine. Yeah, Emil, you can get clocked LED strip, and that can run at higher PWM frequencies, but it's a lot less common, and thus generally a lot more expensive. But yeah, so there's other solutions for that too. Cool. That all works great. There. So, we've already been going about 2 hours. How about we try and replace this temperature sensor and this ESD chip, see if we can fix it, and then see if it breaks again. How about that? I think that's a good ending part of the stream. Let's turn that off. Let's disconnect all of this. Okay, I need to get this out of the way. That's the nice thing about pluggable connectors. You can just disconnect those and you're done. Of course, that doesn't go for the inputs, but that has other disadvantages otherwise. Okay. Now, I've already been doing some stuff here. These chips aren't that big, so we're talking about this guy here. Let's see. Yeah, we're talking about this guy over here, and we're talking about this guy over here. So I think I'm just going to use hot air and replace both of them. I'll get you guys some more light, because I need more light too. 100% there. Okay, so we're going to replace this one over here, U2, and we're going to replace this one over here, U16. So let me get those out real quick. I'm first going to check, how about XT90? Yeah, but I don't know how much room and how expensive XT90 board connectors would be. Do you know, Savak? And then people need to be able to crimp or mount or fabricate or whatever XT90 plugs. And this type of terminal accepts bare wire, wire ferrules, and fork style crimps, and even round crimps if you want. How do you call those? Jesus. Ring crimps if you wanted to. So this is a very versatile, cheap terminal that can handle the load, because I use them on other products too. Yeah. Right, so I need to get an ESD chip and I need to get this one, but I'm going to check the orientation first. And I'm going to do that off screen. So pin 1 needs to be over here. And judging from that little dot over there, this dot over there, it seems like pin 1 is in the correct place. So that is the correct orientation. So that doesn't need to change. Okay. Yeah, exactly, Andy. So I like XT connectors. That's not the problem. But the price and the usability for general folk. Someone who is doing Home Assistant and wants a dimmer board doesn't necessarily know what to do with an XT connector. And he is able to finish some wires in here, or maybe has a wire ferrule crimper or a other style crimper, which are fairly easy to use, right? So that's why I try to stick with connectors that are not too expensive and also usable for general people. So I need a soldering iron. I need some space over here. We're going to need flux, right? We're going to need lots and lots of flux. So let's prepare my flux here. So the first thing we'll do is we'll try and reflow this connector or this chip over here and then see if that makes it work. And if that doesn't make it work, we'll replace it. And I need to see which soldering tip I have on here, and I need to turn my soldering equipment on. Uh-oh, something disconnected. Hello? I'm still here. Don't know what disconnected. So the first thing we'll do is we'll try and reflow this little guy here and see if that changes anything. Let me check real quick. Where is it? There. I don't see any soldering issues. Can I show you guys? No, I don't think so. Maybe like that, I guess. I don't know. I don't see any soldering issues, but we're going to reflow it anyway and see if that helps. Chat keeps blocking your comments. Don't know why. I don't know. I haven't seen any blocked comments there, Andy. Okay, so what? It does look burned, yes. I think they burned it in assembly, but we're going to douse it in flux. And then I'm going to hit it with the soldering iron. One moment. Need to get the right tip. There. And I don't have my fume extractor, but we'll do it without for a minute. And I'm just going to hit the contacts and see if that maybe solves the issue.
Remember all the happy times we had.
Okay, let's check real quick.
Very much alike.
Well, all pins seem to be soldered correctly, but of course it already seemed like that, so I don't know. Let's connect it. I'll still use USB because it's providing power. Oh, I do need Ethernet, don't I? So let's wait for that to power up. Well, I can already tell you, that didn't fix it. Because the I2C bus is still being held low. And, well, that shouldn't happen. That's wrong. Right? No, wrong. Yeah, the pins are mostly beneath the chip, but this is a custom footprint where I bring them out a little bit so I can fix the soldering issue. But that didn't fix it. So next thing we'll do is we'll rip it off and then see if that repairs our I2C bus, right? Let's see if this chip is actually causing the issue, or maybe there's a different issue. So let's get my hot air here. No, wait. Let's get a tweezer. Okay, and my hot air station likes to press my escape key for some reason. Okay, so let's try and hot air this off. I'm trying to show you guys. There. Okay, so looking at the bottom side of this chip, no, it doesn't want to let go. It doesn't look like there's any bridges there, and the solder pads here aren't bridged either. So that actually looks fairly okay. Okay. Well, let's test it. Let's see if our issue is now gone, right? If our I2C bus is now working. There. Well, USB still isn't working. But let's check the logs. Okay, it still can't find the temperature sensor, but it's not on the board anymore. But it does now scan our I2C bus, and it's no longer being held low. The I2C bus has been repaired. So, in that sense, removing this chip fixed the issue that something was holding down the I2C bus. So, okay, in my opinion, that a preliminary conclusion is that that chip is bad, right? Because now I2C is working, and I already did this on another board, so I knew this would happen. And I2C now also works on the connector, for instance. And on that board, I was able to solder on a new chip, and that then worked fine, and to this day still is working fine. So, for now, I'm going to leave it at that. Maybe we'll do that at the end of the stream, but for now I want to focus on this USB chip here to see if that is causing our USB issue. Right? So this is another board that assembly messed up, because I know the circuit is okay, but for some reason this chip was dead, and dead enough to, you know, cause a malfunction on the rest of the board. So let's remove, by the assembly plant. Not the. I think they were okay from manufacturing, but assembly probably botched it up. So let's remove this chip and then replace it. Okay, let's remove it first. Let's douse it in flux. There. Can't really show you because it'll burn the USB plug too. Come on. Well, I'll probably need a bit higher temp. There's a lot of ground plane in this board. Oh, there we go. Okay. I got it. So, looking at this footprint, that looks fine. And the chip, oh, that looks fine too, I guess. Let's go. Okay, so I already know where 1 is because there's a dot there. That's hot. Ow. Let's douse this in flux for a little bit. There. And I think there might be enough solder there already to just put on the new chip. So I'm gonna hold on. Hit the pads a little bit. There. Okay, that should be fine. More flux. Okay, now let me find one of those chips real quick. One moment, please. Okay, we have a new chip. So let's figure out where the dot is. Okay. The dot is... Oh man. Okay, let me clean this up real quick. Okay, no longer sticky, that's good. The dot is oriented like this. You might just be able to make it out. So the dot is in the top left corner. Let's put this to 400. 390, okay. Okay, let's start by heating up the pads. Oh no, I flipped it. Okay, I think that should have done it. Well, there's smoke. Is it my cork on fire? No. Gluing prints is a nightmare? What? Well, it's not on perfectly straight, but I'll take it. As you can see, it's not perfectly straight there, but no contacts are shorted. And I think all the legs are making contact okay. Right? So it's not factory pretty, but it'll do for now. So we need to have this cool down a little bit. Problem is, when I'm making prototypes, I always use low temperature paste so I can easily botch things. But this is using high temperature, lead-free, whatever paste. So it's really hard to heat it up and not burn anything else. Okay, I can touch stuff again, so that's good. Let's get the thermal camera ready. Let's plug in Ethernet. Okay. Yeah, it's cooled down to 56-ish degrees. Oh, you can't see that. Sorry. Let me zoom out a little bit then. Well, you can see the giant hotspot there. But that's cooled down enough. So let's plug in USB. See if USB works again. It does. I heard the pling pling. So, resoldering that ESD chip fixed our issue. Right? So, there might actually be a schematic issue where 24 volt is reaching the ESD chip. So let's test that. We're actually trying to fix stuff there, Christian. Let's see if I can put my multimeter on screen. There. Okay. So nothing should be here, I think. No. It's okay. That's good. Let's see about here. 4.8. 4.8. That's correct, because that should be the input to this guy. Yeah, 4.3, and that should be making, well, 3.3, but 3.2 because it's powered over USB. That's fine. Okay. So I believe the power pin is this one here in the middle. And that's getting 4.3 volts. That's fine. Ah, I might know what's going on here. Interesting. Maybe the input to that pin is actually connected to the power input. Shouldn't be, but maybe it is. Because I used to have a double fuse or a double diode there. And I think I removed it, but well, we'll see. We'll see. So this works now. I have a USB connection. Let me check in Device Manager to make sure. Yeah, COM5 CH340. This works perfectly. Good. Okay. See, this is why I build pre-production prototypes. No, we're going to turn on the board anyway, Emil. So we might as well just turn on 24 volt and see what happens. Right? Maybe the power connection for the ESD chip is not behind the diode. Should be, but we'll see. Oh wait, thermal camera. Okay, well, the whole board is warm still. Yeah. I don't feel like waiting for that. Let's, Exactly, Earth Gamer, yeah. So let's see there. Do I see that chip heating up? Not really. So let's measure the voltage that it's currently getting. No. Yep, there's our problem. The ESD chip is getting 24 volts. That's not right. Yep. Okay, double verified it. Yeah, okay. Yeah, well, that's gonna kill it. That's for sure. Okay, well, this stream was very useful. I have a problem there I didn't know about. That's easily fixed in schematics, that's fine, but... yeah. That should not be connected like that. How did that happen? Because the ESD chip only needs to turn on when there's USB, so it should be connected to VBus, not to anything else. Right? So, if we check this diode, nothing. Well, this is a fuse, by the way. Okay, let's check the diode. Okay. Yeah, so it should be behind this diode because it's at 0.6 volts, that's fine. And the other side of the diode is 23.7 volts. That's good. So why then isn't it behind it? Because this fuse is in between USB. That's also getting 0.7 volts, that's fine. So that's behind the diode. And this circuit should be connected to that point, but it isn't. Okay. Well, that explains the exploding USB. And we were able to fix it. It's probably dead again. Let's see if it's dead again, right? No, the diode is the right way around because the 24 volt isn't making it to the USB plug. That's correct. Nothing happens. Nope. Nope, it's not doing anything anymore. I'm not even hearing a ping like anything's getting connected. It's just dead. Okay, kill it again. Yep, that's right, Barry. Oh, okay, that's fine. That's the result. Okay, shall we try and replace this temperature sensor and then call it a day? I think we shall. No, we tested it. 24 volt is not going back into the USB plug. That is for sure. But it is going to the ESD chip. And, well, that shouldn't happen. Oh, you mean it could be on the data lines? Yeah, I guess that's a good point. I have no clue how that happened. Interesting. Well, we're at V1 revision 0B. We'll go to revision 1, version 1, revision 1 for the production release. So, yeah. Okay. Let me fix those pads a little bit. Okay, might need a little bit more solder. I believe this is some of my low temperature stuff. So let's try that. Okay. Yeah, that one's challenging because the footprint is so small. And now there is too much solder on the middle pad. I know that's gonna. I already know that. But the other pads have a decent amount of solder now, at least. So let me get one of those. If I remember where I put them, they might actually still be here. No. Oh, did I put them back? I don't remember. No. Wait, what? Serial alarm, resistor, capacitor, resistor, MOSFET, plug, thermal, capacitor, big capacitor. Where's my sensors? Oh, why is this? No. Oh! My sensor tub is already on the table. So, anyway. No. Now, I somehow remember them not putting them back because I knew I was going to need them soon. And I put them in a place where I could quickly get them, so now I've lost them. Does anybody remember have that happen to them? I know they're on my desk though. Hey Philip. Yeah, there's actually a problem on the board which is blowing up the USB ports or the ESD chip on the USB ports. Can somebody else fill them in? I need to find my bag of sensors. Oh wait, I think it's over here maybe. No, it's not. Damn it. Where did I put those sensors? Trying to find them. Nope. Well, there was smoke, but it was from my my onderzetter, my coaster. Where the hell did I put that back? So this isn't it, sadly enough. I'll put it in here. No. I knew I should have put it back in the box when I had a chance. But I didn't. I thought I'll put it here. There it'll be safe. I'll be able to find it there immediately. 1 hour later. It's gone. Where the hell is it? Don't understand. Huh. Only explanation is that it fell off my table, but then it might have fallen into oblivion. Nope. Okay. Where could it be? I know there was a random box here somewhere. Was it this one? Yes. I don't understand. Oh, I did find my easy buck converter prototype. So this plugs into the board and automatically it transforms the voltage for the digital LED strip only. It has to be on my desk. But it's not. One moment, guys. If I can't find it, we'll have to do without. I just don't understand where it could have gone. Come on, chair. No, I didn't quit. Oh, wow, we had a lot of frame drops. Are we back? My internet line isn't filled up. I don't know what's going on. 6,000 dropped frames. It's the wrath of Ziggo. Yeah, I think so. Now it's fine again. I didn't change anything. My internet line is fine. I have like half my upload free. So, what? Very odd. What is going on? Where are those stupid sensors? Nope. Okay, I didn't change anything. It's just my provider being in, well, I actually just stopped mentioning that I really like them because they never caused an issue, but then maybe they've started causing an issue? I don't know. Yeah, I don't think I'll be able to find my sensors. I know I used them past week. And I know I put them right there. Yeah, it could be YouTube. That's possible too. This is annoying. I hate losing stuff. I know I put them there. But where else could they be? Cybermono needed them to fix his board. Yeah, maybe Ziggo needed them to fix their equipment. Or YouTube. Okay, I'm going to give myself another 1 or 2 minutes, and if I don't find them by then, we're skipping it. And I'm quite certain what I did with them, so I don't understand why they aren't where I put them. Why they ain't where I put them. No. No. Nope. Nope. Well, this needs to be somewhere else anyway. You're promoing MakerCast there, Johnny? That's fine. Okay, let's get this LED strip out of the way. I don't understand. I'm 100% certain they have to be here. Nope. No drops on my side. Yeah, maybe put them in here. No. Or they may be back here. No. nope, 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 nope. Oh, I can't stand losing something like that. I know I should have put them away when I was thinking, I'll just put them here. I'll need them in a few days anyway. Stupid. Yeah. Okay, well, that's it. I officially can't find them. But I'm going to need them later anyway, so that sucks. Yep, no clue. Okay, that's fine. No, I didn't use all of them. I know I had the bag, and I know I put them down, thinking I'll just put them here because I'm going to use them later anyway. Literally that thought. And I also know it was right here. Where the hell did my mouse go? My desk is a giant mess now. And I know I put them there thinking like, okay, I'm going to need them more anyway. And now they're gone. Shouldn't have done that. Should have just put them back in the box. Wow, there's like giant strings of LED strip here. Go away. I'm annoyed now. Okay, we're going to do one last thing this stream. And then we're going to end it because now I'm annoyed. Because I really wanted to put that temperature sensor on there to see if that fixes it, and it stayed fixed. Okay. Refocus. What we're going to do is we're going to use this little thingamabob, and this is a DC to DC converter, 50 watt, input 12 to 24 volt, output 5 volt, right? So instead of our 24 volt digitally addressable LED strip, we're going to be hooking up a 5 volt LED strip while still using the 24 volt power supply. And the way we do that is basically just by adding this thing. Boop. Done. So it just plugs in like that. And once the case is on there, it should lie on the case like that, basically, right? And then we're going to take our plug for our digitally addressable LEDs, which is now in this giant pile of mess here. Oh my god. Nope, wrong side. Okay. Well, no, there's no secret today. There's an Quindo is annoyed time, maybe, but no secret. We're going to take our little 3-wire plug here, which we used the last time with 24 volt strip, but then the 24 volt came from here, but now the buck converter is on there. So we're going to unscrew that. Now this whole stream is a sneak peek and a secret. So we don't need this guy. And now we're going to put the 5 volt, which is coming from the buck converter, into this terminal. Okay. So we have our 5 volt, our data, and our ground here. And before we got power from this terminal, but now this terminal is going into the buck converter and out of it again, making 5 volt on this plug, going to this one, out of 24 volt. And that way we can run a 5 volt LED strip on our 24 volt power supply, even while we still have analog. Let's connect those two LED strips. And where is our RGB? No. There's so much mess here. I think after the stream I'm just gonna close the door and I'm done. Quinder can get annoyed. Yeah, at some point I get annoyed. It's not easy, but I can. So, looking a quick overview of our ports here. Go away. Ah, I still need to connect this to this. There. Quick overview of our ports. We have 24 volt coming out of here, and then a single negative channel out of these two. Again, 24 volt here, single negative channel here, RGB, so 3 negative channels. Then we have positive 24 volt, negative 24 volt, negative 5 volt, positive 5 volt, again positive 5 volt, data, and ground. So I hope that makes sense. I'm just going to turn on the power supply and hope nothing explodes. I see green lights, that's good. I have no clue where those temperature sensors are. It makes no sense. I put them right there on my... Whoa, whoa, whoa. Well, Philip, you were in time. Did you see that? Did you see the smoke? That ESD chip there burned like hell. Yep. Yeah, that's burnt. Okay. So, Philip, you were in time. There was definitely smoke there. I can't really show you that well. How is the smell? The smell is like burnt electronics. Can you see that leg? The middle one, that is the positive voltage input. I'm trying to show you. Come on. Nope, other way around. There, can you see the burn on that leg? That was magic smoke. No, I won't be putting a USB-C cable in there right now. We got it. We got it. That little ESD protection chip there burnt like hell. Oh, okay. So, let's see if our other circuit is working. Yeah, it came from over here, from the ESD chip. But, okay. So, let's go into Home Assistant. And we should have a board that's online. Let's turn on the digital power. So, we should see this LED flip on. Yep, we did. There's our blue little LED. So, now the buck converter is getting power. And then we should be able to turn this on. Well, it's configured for 100 LEDs, so that's correct. And let's put it to rainbow. Cool. Wait, that's not right. I need this one. So it's configured for 100 LEDs and not 300, so that's why we're only seeing 100 LEDs. But this is a 5 volt strip running off of a 24 volt power supply using my little buck converter convertery thingy here, which is just a simple plug-in module. So my intention is to basically sell these as is, pre-cabled, so that if people want to run 12 volt or 5 volt LEDs, they can either buy these buck converters themselves and make the cables, that's fine, or they can buy it pre-wired and just plug it in, and then they can use 5 volt or 12 volt LEDs. Yeah, I need to figure out what went wrong in that circuit. I don't know. Everything else is working. But yeah, that's fine. That's why we do prototype boards. And on another board, I replaced that temperature sensor, and then I lost the bag. I'm so annoyed by that. And then the temperature sensor worked fine, and it kept working fine. So I know how to solve that issue, or rather, that's not an issue I caused. Yeah. But hey, that's how development goes. Sometimes there's an error, and I don't know why that error is there. It shouldn't be, but it is, and we'll fix it. Likely this is an issue in these two boards there, Event CJ, because the input stage for the 5-channel high power and for the 15-channel is basically the same. The AN Mini is different. I don't have any experience with the other type of level shifters than the ones I use, basically, the HACT ones. Yep. So yeah, addressable 5-volt LEDs with a 24-volt power supply by easily plugging in little buck converter here, which you can just glue or, Velcro to the case. That's the idea. So this, in that sense, becomes the ultimate hybrid board. Let's see if the analog stuff is still working. Probably is. Yep, we got blue. Oh, well, you can't see that. There. Ow. Ah, that's a lot of blue. Cool. And let's do some. Here we got cool white also. It's all the same color as blown out. Hold on. There. Cool white and blue. Oh, I accidentally refocused it. Okay. This board has 4 layers. Yeah, either I punctured a via, which I didn't notice, or that's happened before for some reason in KiCad, or there is just a schematic error and I oversimplified this circuit for this final pre-production model. But I'll find it and I'll correct it. That's no problem. So, wow, I'm so annoyed. I don't even mind that ESD chip problem. That's just, it happens. What type of level shifter do you use in your Octa boards? It's also an AHCT variant, but then a 4-channel variant, and there's 2 of them on there. Yeah, I'll probably spend the rest of the night trying to find those freaking sensors. Oh man, I can't stand that. I hate that. Where are they? Okay, anyway. I'm going to open another Coke with you guys. Here it is. We're not going to put any sticker on it. And I'm just going to hang out for a few more minutes and enjoy the last part of the stream. We also had a lot of technical issues today, didn't we? I don't understand where these lag spikes are coming from, because if I look at my router, there was 0 issues. Yeah, I will, Dutch Towers. What other board? With my stickers? No. No, I probably misplaced them somewhere. Because I know I put them right here. Exactly here. Bets are on 5 minutes after the stream. I don't know about that. We'll see. I just don't get it. I probably cleaned up and then I got lost. Philip, finally smoke and an annoyed Quinder as a bonus. We don't see that every day. Amen. Oh, Amaury, that sounds like something is wired wrong there. Hey there, Ray Bame. Your mom would find it in 10 seconds. I don't know about that, but I'm so annoyed. They're in a little baggie like this, you know, and it has a perfectly good label, and it has its own box that it goes into, the sensor box, and I didn't put it back in there, and when I didn't do that, I thought to myself, I should put them back in. You're going to lose them. Yep. And there's like $20 in there too, because there's like 20 sensors in there, which are $1 a pop. Oh well, what you gonna do? Amaury, when you're wiring it up, make sure the backup channel is connected to ground and not to data. Maybe that can change it. And I don't know what's going on with the stream, because right now it's perfectly fine again. You already posted that, Amaury, and I already responded also. One thing I do like about these boards, they do look cool. It's like the most important things, that your PCB looks cool, right? Well, Emil, you could also not have them hooked up correctly, but it's hard to diagnose that like this. Okay, I've calmed down a little bit. Yeah, that's what happens, Earth Game Rexy. But you can take it out. I won't prevent you from taking it out. And I won't prevent you from flashing it or anything like that. You buy it, it's yours. You do with it what you want. But, yeah. And once you buy it, it'll have a freaking working temperature sensor. Yeah, well, the temperature sensors are in heaven. They're gone. They were like, we're never going to be soldered through that guy's board. We're out of here. Let it go. Let it go. Yeah, I'm not getting it. Letting it go. There will be a search tonight. I can guarantee you that. And then I don't know if I'll actually solder them on. As long as I have them in my hands, I'll put them in the right box again and be like, I win. But we'll see. We'll see. I do appreciate you guys hanging out for this long, because it's now over 3 hours, and a lot of you guys are still here, so that's appreciated. I asked before, but you might have missed, will these parts be available from China for us if we wreck a board? What do you mean? You can buy all these parts. They're not that special. What I do is compile them so they work together and the right parts, but each individual part you can get. So I use a AHCT level shifters. But you can check out my DIY digital boards, and there you can see which level shifters I like to use. Emil Bart's almost falling asleep. I'm too annoyed to sleep. I keep looking. I should stop. I'm just not gonna look. I'm gonna look somewhere else. I'm gonna look over here. You know, it's a nice cupboard. Some pretty LEDs. Are they over here? No, stop. Okay, guys. I'm calling it a day. Thank you all so much for suffering with me. And I'll let you know in the Discord when I find those temperature sensors. And maybe I'll solder it on the board. But I'm not sure it still deserves that. I don't know. We'll see. Thanks all for watching. And catch you guys next time. Bye-bye.